Hopefully everything's going really well. So if you haven't done this yet, you can pause this, but everybody needs to grab a compass and a ruler, and then we're going to draw some things. So you need to pause this so everybody can grab a compass. If the compasses aren't in here, Mr. Bard has them. You can borrow them back from Mr. Bard, but if you need to pause this, go ahead and pause this, and then come back and we'll start the film, okay? If not, if you're ready to go, then we'll get started. Okay, so grab a compass and draw a circle with radius 5 centimeters. So I'm going to make sure that it is 5. So I take my ruler, make sure my compass is 5 centimeters. Okay, it's 5. Got matched right just to 5. Looks pretty good. So I'm going to draw a circle, radius of 5, and poke it right about here. Draw this over here so you guys can see what I've got. Okay, I'm going to do this. Okay, like that. Okay, there we go. Okay, there's my circle. And I'm going to make some labels. I'm going to put C for the center right there, okay? Okay, grab a compass, draw a circle, radius 5, so it's circle C. So, in circle C, we're going to draw a quadrilateral ABC. So first of all, let's just draw this radius here. We're going to call this AC, okay? Straight across, AC. Then I'm going to draw this radius here, right down there, call that D. All right, so I drew my circle. I made radius AC, and I made radius CD. Now, what I want to do is right here on the tangent, okay, I'm going to draw kind of like a little tiny tangent line right here. Okay, actually I'm going to go a little further than that. I'm going to put a point down here, right down here. Okay, draw a point right down here. Let's call that point B, okay? Point B, okay? Now, I want to connect from D to B, and I want to connect from A to B, okay? So what I've done is I've constructed quadrilateral A, B, C, D. I kind of have the numbers out of sync, but it's going to work, okay? And I'm going to draw this line segment from C to B, okay? Okay, I'll give you a second. I want that quadrilateral right there. Now, what do you know about AC and AD? Yeah, they're radii. So the radii of the same circle, so the radii, the same circle. So we know that they're congruent. So I can say AC is congruent to CD. They have to be the radii of the same circle. So I'm going to write that down for sure, okay? What do you know about AB and DB? AB and DB. Well, sure looks like AB is bigger, doesn't it? AB sure looks greater. So I'm going to say AB is greater than DB. Definitely looks like AB is bigger than DB. In fact, yeah, I'm pretty sure about that because what I know about the angles, okay, I know that this angle looks like about 90 and this was less than 90. So I know that angle ACD, that's the full angle, and DC, hold on, ACD, oh darn it, I meant to say this angle here, I meant to say ACB, change that to a B, my bad, angle ACB, and angle DCB, that's correct, and angle DCB. Hopefully you're going to say that angle ACB is greater than angle DCB, okay? Now I call this the hinge theorem. The hinge theorem. It's really pretty simple. It's like a hinge. As it opens up, the bigger the angle, the bigger the side. That's why it's called the hinge theorem. It's pretty simple, isn't it? Okay. Alright, so that's what we're going to talk about today is if an angle, the bigger angle obviously is opposite the bigger side, so if you want to compare two angles, if this side is bigger than this side, then this angle is bigger than this angle, or if this angle is bigger than this angle, if this angle is bigger than this angle, then this side. It's the opposite side. So we're looking at the opposite sides and opposite angles. Okay, it's pretty simple. Same kind of thing we talked about yesterday except for comparing two different triangles. Okay, so go ahead and grab your journals. If you want to pause for a second to grab your journals, go ahead. And we're going to go straight to page 219. So hopefully guys, back page 219, page 219. Okay. All right. So hit the Heron's theorem. Here it is. It's really pretty simple. I mean, this shouldn't be. I've got one problem that. A couple of problems are going to take us a little time, but mostly it's pretty easy. Okay. Take a look at this. If angle V, obviously angle V is bigger than angle R. Okay. If that's the case, if that angle is bigger than this angle, then we know that WX has to be greater, so this side has to be bigger than that side. It's just that simple. And of course the converse says just the opposite. If this side is bigger than this side, okay, you have to have two equal sides, then we know obviously that angle C is bigger than angle F, okay? So here's the Heron's theorem though. We're talking about the exact same hinge. So if you think about it as one triangle, here it is, and if they close this triangle down, you get this triangle. Okay, think about this triangle. Okay, if you take this triangle and you close it down, you get this triangle. So obviously if you're closing it down, you're making a smaller angle. That's why it's called the hinge theorem. Okay, turn the page. I want you guys to go to page 220, so it's super easy. This was really easy. Really, really easy. Okay, 220, page 220. So, what do you know about BC? Well, if this angle is smaller than this angle, BC is less than EF. Easy peasy lemon squeezy, right? Number two. All right, 95/20. So obviously BC is greater than EF. It's that easy. So you have to really think of it as one triangle that's been closed to make the new triangle, okay? Or you have to think about one triangle being opened up to make the new triangle, okay? Okay, 3. So obviously 90, 90, so these two sides have to be equal. It has to be equal. BC has to be equal to EF. Exact same triangle twice, so we'll say it's equal or congruent. Okay, now 4 just does just the opposite, right? Okay, if I know all three sides are equal, then angle A, which is right here, and angle D, which is right here, obviously they're equal or congruent. Okay. If this is 14 and 16, then angle A is less than angle D. It's that easy. 6, that's 9, that's 2. You can even see it. So obviously angle A is greater than angle D. Okay, now those are easy. So let's do a really good problem, okay? So I'm going to do it on a separate sheet of paper, okay? Actually, you know what? Maybe I'll draw it here. We can scribble out 13 so it's in your journal, okay? Let's draw this picture, okay? I want you to draw the following picture, okay? Draw this. And draw this. Put that right there. Okay, draw that triangle like that. And I want to draw this and this like this. Okay, I want you to draw a triangle like that. Okay, so I'm kind of making a problem because I think the book's problems are kind of weak. I want a good problem. This side's 5, this side's 6. These two sides are equal to each other, okay? So what I see as you're drawing this is two different triangles. I really do, okay? I really do see two different triangles, okay? Hopefully you're drawing this. Okay, I see a triangle. We'll call it the orange triangle. And we'll call it the other one the yellow triangle. Hopefully you guys have constructed that. You've drawn that. It doesn't have to be perfect. Just make it be as nice as you can. Right now, here's what we know. We know between the orange triangle and the yellow triangle that they both share the side. So basically they're the exact same shape except for this opposite side is 5 and this opposite side is 6. So I know that the angle, let's call this angle A, okay? We'll call this angle B. I know for a fact that angle A is less than angle B, okay? 5, 6, angle A is less than angle B, okay? So let's say that angle A happens to equal 3x plus 1, okay, put that in there. Angle A is 3x plus 1. And let's say angle B is 25 degrees, okay? So if that's the case, angle A is still less than angle B, so let's write an inequality. We're going to write an inequality. So if angle A, I'm going to say, okay, 3x plus 1 is less than 25 degrees, okay? So no matter what, angle A can't be 25, right? Angle A has to be less than 25, right? So let's solve for x, okay? So if we solve for x, minus 1, I'll have 3x is less than 24. Divide by 3, x is less than 8. Okay, good. X is less than 8, that's awesome. So if I put in 7, if I put in 7, 3 times 7, 21 plus 1 is 22, that is less than 25. That works. I put in less than 8. Let's see if I put in 4. 3 times 4 is 12, plus 1 is 13. That is less than 25. Good, okay? But there's one other thing that we have to be careful of. Angle A can't be 0. Okay, so there's more to this picture, okay? There's more. Angle A has to be greater than 0. Has to be. Because if angle A is 0, there's no angle. Okay? So that means that 3x plus 1 must be greater than 0, okay? So what's the value of x that makes us make sure that this angle will always be greater than 0? Because if it's 0, there is no angle there. So let's solve. Minus 1, 3x is greater than negative 1. Divide by 3, x is greater than negative 1/3. So here's what we know. In order for this picture to work, the value of x must be less than 8. Because if it's more than 8, it's going to be bigger than b. It can't happen. Okay? So x has to be less than 8 in order for a to be smaller than b. But we also know for angle A to exist, it has to be greater than 0. So the value of x also has to be greater than negative 1/3. So all the value of x's are in between negative 1/3 and 8. So we can say negative 1/3 is less than x, which is less than 8. Okay, that's what I have for you today. You have some homework. Mr. Fredericks passed out your homework to you, and I'd like you to work on that, and then he can put on the film when he feels like you're ready. Okay, there you go.